Lectricalc version 4 by Electric Smarts is a popular electrical software program designed for Windows-based personal digital assistants. It provides a wide range of features for performing electrical calculations. These features include wire sizing, load calculation, voltage drop calculations, short circuit analysis, ground fault analysis, transformer sizing, motor sizing, and equipment selection. Some advantages of using Lectricalc version 4 include its easy-to-use interface, its ability to perform comprehensive calculations, its support for the National Electrical Code (NEC) and the Canadian Electrical Code (SEC), its large database of electrical equipment, and its ability to generate detailed reports. However, there are also some disadvantages to consider. Firstly, its functionality is limited compared to desktop software. Secondly, it can be slow on older devices. Besides Lectricalc version 4, there are other electrical software programs available for Windows personal digital assistants. One alternative is eCalc Pro, which offers similar features to Lectricalc. Another option is Pocket Electrician, a free and open source program with a more limited feature set. Electrical Notes is a collection of electrical calculators and reference materials. Lectricalc 101 is a basic program for simple electrical calculations. Electrician Tool is a suite of electrical calculators and tools. If you require a comprehensive electrical software program for your personal digital assistant, both Lectricalc version 4 and eCalc Pro are viable choices. If you need detailed calculations and reporting features, consider Lectricalc. If you prefer a more user-friendly interface, eCalc Pro might be a better fit. For basic calculations or reference materials, Pocket Electrician or Electrical Notes could be sufficient. The best option for you will ultimately depend on your specific requirements and preferences. When sizing wires, ensure that the selected wire gauge can handle the calculated load current without exceeding its ampacity rating, as specified in the National Electrical Code, NEC Table 310.15b16. The NEC provides ampacity tables that list the allowable ampacities for various wire types and sizes based on their insulation temperature rating and installation conditions. When performing load calculations, it's crucial to consider all connected loads, including lighting, receptacles, motors, and heating equipment. The NEC provides guidelines for calculating the demand factors for different types of loads, which can help to reduce the overall calculated load. For voltage drop calculations, the NEC recommends limiting the voltage drop in branch circuits and feeders to a maximum of 3% and 5% respectively. Excessive voltage drop can lead to reduced equipment performance and potential overheating. Short circuit calculations are essential for selecting appropriate overcurrent protection devices, such as circuit breakers and fuses. The calculated short circuit current should be less than the interrupting rating of the overcurrent protection device. Ground fault calculations are important for ensuring the safety of personnel and equipment. Ground fault protection devices, such as ground fault circuit interrupters, GFCIs, and ground fault equipment protection, GFEP, can detect and interrupt ground faults, preventing electrical shock and equipment damage. When sizing transformers, consider the total load that the transformer will supply, as well as any future load growth. The transformer's kilovolt amp kVAR rating should be greater than or equal to the calculated load. Motor sizing involves selecting a motor that is appropriately sized for the driven load. The motor's horsepower rating should be sufficient to meet the load's torque and speed requirements. Equipment selection involves choosing electrical equipment that is suitable for the intended application and environment. Consider factors such as voltage rating, current rating, environmental conditions, and safety features. When using electrical software on a personal digital assistant, it's essential to ensure that the device is properly charged and that the software is up to date. Regular software updates can address bugs, improve performance, and add new features. Also, be aware of the limitations of using a personal digital assistant for electrical calculations. The small screen size and limited processing power can make it challenging to perform complex calculations or view detailed reports. For complex projects, it may be more efficient to use desktop software or consult with a qualified electrical engineer. Before making any electrical modifications, be sure to consult with a licensed electrician and adhere to all applicable codes and regulations. Improper electrical work can be dangerous and may result in property damage or personal injury. The National Electrical Code (NEC) is a comprehensive set of standards for electrical installations in the United States. It is updated every 3 years and provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical safety. The Canadian Electrical Code (SEC) is a similar set of standards for electrical installations in Canada. Familiarizing yourself with the NEC or CC is essential for anyone working with electricity. The electrical calculations can be complex and require a thorough understanding of electrical theory and principles. If you are unsure about any aspect of electrical work, it is always best to consult with a qualified professional. Electrical software can be a valuable tool for electrical professionals, but it should not be used as a substitute for proper training and experience. Always double-check the results of any electrical calculation to ensure that they are accurate and consistent with industry best practices. When working with electricity, safety should always be the top priority. Wear appropriate personal protective equipment (PPE), such as safety glasses and gloves, and follow all safety procedures. Never work on live electrical circuits unless you are properly trained and authorized to do so. De-energize the circuit and verify that it is de-energized before beginning any work. Always use properly rated tools and equipment and inspect them before each use. If you are working in a hazardous location, such as a wet or dusty environment, take extra precautions to protect yourself from electrical shock. Be aware of the potential hazards associated with electricity and take steps to mitigate them. Electricity can be a powerful and dangerous force, but with proper knowledge and precautions, it can be used safely and effectively. Electrical software for personal digital assistance is a useful tool for performing electrical calculations in the field. However, it is important to use it responsibly and to always prioritize safety. Remember to consult with a qualified electrical professional if you have any questions or concerns about electrical work. Furthermore, consider voltage drop calculations for ensuring efficient power delivery. For instance, if a circuit has a long wire run, the voltage drop can be significant, potentially affecting the performance of connected equipment. The formula for voltage drop is typically expressed as voltage drop equals 2 times the length of the conductor times the current times the impedance per unit length divided by 1000. This calculation helps determine the appropriate wire size to minimize voltage drop and ensure that equipment receives the required voltage. It is also essential to consider the ambient temperature when selecting conductors. The ampacity of a conductor decreases as the ambient temperature increases. The NEC provides correction factors for ampacity based on ambient temperature. Refer to NEC Table 310.15 for these correction factors. Similarly, dirting factors are applied when multiple current-carrying conductors are bundled together in a raceway or cable. The heat generated by the conductors can raise the temperature inside a raceway, reducing the ampacity of each conductor. NEC Table 310.15b3 provides dirting factors for various numbers of current-carrying conductors. When performing short-circuit calculations, consider the available fault current at the service entrance. The available fault current is the maximum current that could flow during a short circuit. This value is typically provided by the utility company. The overcurrent protection devices must have an interrupting rating that is equal to or greater than the available fault current. Ground fault protection is designed to protect people and equipment from ground faults. A ground fault occurs when current flows from a live conductor to ground. Ground fault circuit interrupters, GFCIs, are required in many locations such as bathrooms, kitchens, and outdoor areas. GFCIs trip when they detect a small imbalance in current between the hot and neutral conductors, indicating a ground fault. Ground fault equipment protection, GFEP, is used to protect equipment from ground faults. GFEP systems typically use a current transformer to monitor the current flowing to ground. If the current exceeds a certain threshold, the system will trip the circuit breaker. Transformer sizing involves selecting a transformer that is large enough to supply the load. The transformer's kilovolt amp kVAR rating should be greater than or equal to the calculated load. Consider the power factor of the load when sizing transformers. The power factor is the ratio of real power to apparent power. A low power factor can increase the current drawn from the transformer, requiring a larger transformer to be used. Motor sizing involves selecting a motor that is appropriately sized for the load. The motor's horsepower rating should be sufficient to meet the load's torque and speed requirements. Consider the starting torque of the motor when sizing motors. Some loads, such as pumps and compressors, require high starting torque. Electrical equipment selection involves choosing equipment that is suitable for the intended application and environment. Consider the voltage rating, current rating, environmental conditions, and safety features of the equipment. Choose equipment that is listed by a recognized testing laboratory such as Underwriters Laboratories or Canadian Standards Association (CSA). Electrical software can assist in performing these calculations and selecting appropriate equipment. However, it is essential to verify the results and to consult with a qualified electrical professional if you have any questions or concerns.